All right, so this is live class. We're doing the raft problem for vector addition. And so what we've got is we've got three different vectors. We have a raft that's out in the middle of the ocean, and we have Joao is lost on this raft, and he decides he wants to go north for some reason, so he's paddling north at 2.5 meters per second. Meanwhile, the wind, it's pushing him east at 1 meter per second. And then there's a current, which is off at an angle, which makes the problem harder for us at 3.5, 20 degrees north of west. And the question just asks, well, what direction is he actually going to go? Which he'd be interested in because he wants to know if it's going to get him towards an island or not as he's out there in the middle of the ocean. Okay, so what we do is we organize this by just sort of drawing the vectors involved. And if any of them are at an angle, we go ahead and we put the components in. So let's look here. So we've got 2.5 north. And I'm going to try to make the vectors approximately to size. These are all meters per second, so I'm going to leave off the units. We've got east at 1, so that's a little smaller, something like that. Okay. And then we've got north of west. So if you make a little compass reference line, 20 degrees isn't a whole lot, so this is a pretty sharp angle. 3.5 is bigger than the 2.5, so I'm making it a little bit longer there. And there's my 3.5. That's north of east. Thank you very much. So let's redo that. Let's see if I can just flip that. Left, right. That didn't work. Very nice. So I'll just start over. Thanks for the help. So I'm going 20 degrees north of west at 3.5. And now what we're going to do is we're going to get the components. So we take this, and with the 20 degrees, we can do sine and cosine. And what do we get for the west one? Anybody? Yeah, so it'll be 3.5, and then we do cosine 20 degrees. The other one will be 3.5, and we do sine 20 degrees. Sorry? 3.3? And then the other one? 1.2. So we rounded these a little bit, and if you decided not to, if you decide to have more digits here after that, that's fine. But we're just showing the process more than anything else here. So now when we, yeah? Well, let's just take a second and see what our real numbers would be, and then we can check. So I'm going to go 3.5, and then sine of 20, so 1.19, so 1.2 looks good, and then 3.5 cosine 20 looks like 3.3, so it looks pretty good. Okay, so when that happens, the most likely thing is to check your mode. So see, when you check your mode, you want to make sure that you are not in radians, but instead are over here in degrees. Because if you did it in degrees, you got it right. But if you did it here, you'll notice that even the same exact thing, I get a very different number, right? I'm getting 1.4, which is very confusing because you'd think that could be a reasonable answer, but it's just wrong. So it's important. That's a good point. It's important to check, especially if your math class is doing radians. It's important to check that you're in degrees when you're doing these problems. So awesome. So we've got 1.2 north, 3.3 west, and notice that now this 3.5, I'm not going to be using it anymore when I go to do the problem. Instead, it's more important for me to realize I'm going to use the 1.2, right? And I'm going to use the 3.3. Did you like that? I can use the 1 because it's on an axis line, and I can also use the 2.5 because it's on an axis line. But this 3.5 is dead to us now. We don't want to use it at all. Okay? So now we're going to say, okay, well, what overall's happening? What's the actual overall velocity? And velocity includes angles, so we want to be careful there. I actually asked twice, what's the speed? And then I also ask, what's the velocity? And I do that to make the distinction. So let's take a look at what that means. So overall, we have 2.5 north and 1.2 north. North and south, nothing else is happening. Right? So we're going to be going north at 3.7. That's for sure. Yeah. And then west, excellent, because 3.3, which is west, is bigger than the 1, which is east. So we'll end up going, I guess, 2.3, because they cancel. So 2.3 this way. So we end up with a 2.3 west. And these are both meters per second. I've been lazy not putting units on here. I really should have units. Okay? And so now we need to get this. And if all I'm asking for is speed, then all you have to do is the Pythagorean theorem and get that answer there, where you go ahead and take sorry, 4.4. So we have 4.4, and if the answer is for speed, we're done. But it's asking for velocity, and in your vocab, you know that speed does not include direction, where velocity does include direction. So we need to put the angle in here. This angle, as I've drawn it, you'll notice is going this direction from the compass line, and so we would say west of north. If you drew the triangle the other way, you could have north of west instead, but you'd have a different angle. So we're going to arctan. Yeah. What's up? Okay. Can you just write a quick message? Tell him to follow on the Thursday page. I'm about to cut and paste this onto there, so he can at least follow along as we go. So did someone get an angle here? It looks like it should be less than 45. Sorry? 31.2. Thank you. So we have 31.2 degrees, and this is west of north. Okay? And that's how you do that problem. And I'm going to go ahead and stop recording.